This week we're looking at functions. So first, let's determine whether the equation here, y squared equals 4 minus x squared, defines a function. I'm going to start by solving for y. So I'll take the square root of both sides. We have y is equal to plus or minus the square root of 4 minus x squared. So, because values of x result in more than one y value, we have a positive and a negative, this is not a function. So a good kind of key is if we have a y value that's defined to be plus or minus something, we probably don't have a function. F of x equals 2x plus 1 over 3x minus 5. So this is getting used to function notation and evaluating a function for certain values of x. So first, we're looking for f of 0. So everywhere x is in the original function, we're substituting in 0. So 2 times 0 plus 1 over 3 times 0 minus 5, which equals 1 over negative 5, or negative 1/5. Let's look at f of 1. So 2 times 1 plus 1 over 3 times 1 minus 5 equals 3 over negative 2. C is asking for f of negative 1. 2 times negative 1 plus 1 over 3 times negative 1 minus 5. Negative 1 over negative 8, which simplifies to 1/8. D wants to know what f of negative x is. So I replace x with negative x. 2 times negative x plus 1 over 3 times negative x minus 5, which is negative 2x plus 1 over negative 3x minus 5. This is correct, but it is often simplified by factoring out the negatives in both the numerator and denominator and canceling them, which would result in 2x minus 1 over 3x plus 5. E wants to know what the opposite of f of x is. So it's the opposite of 2x plus 1 over 3x minus 5. So be careful when you're doing this that the negative is out in front of the whole entire fraction here. F wants f of x plus 1. So 2 times x plus 1 over 3 times x plus 1 minus 5. Distributing, we have 2x plus 2 plus 1 over 3x plus 3 minus 5, which simplifies to 2x plus 3 over 3x minus 2. G is asking for f of 2x. 2 times 2x plus 1 over 3 times 2x minus 5, which is equal to 4x plus 1 over 6x minus 5. Finally, H, 2 times x plus 1 over 3 times x plus h minus 5. Distributing, we get 2x plus 2h plus 1 over 3x plus 3h minus 5. And this doesn't simplify anymore. Let's find the difference quotient for f of x equals 2x squared minus 3x. Now the difference quotient is defined to be f of x plus h minus f of x over h, where h does not equal 0. And this is a concept that will become important when you study calculus. So I will substitute in first x plus h for x and get 2 times the quantity x plus h quantity squared minus 3 times the quantity x plus h. So that was my f of x plus h. I'm going to put parentheses around it for now. minus, now we'll write f of x, which is 2x squared minus 3x, all over h. Let's start simplifying. 2 times, I'm going to expand out x plus h quantity squared and get x squared plus 2xh plus h squared. I'm going to distribute the negative 3, so minus 3x minus 3h. I'm going to distribute the negative as well in the next expression, so minus 2x squared plus 3x all over h. Now I'll distribute the 2, so I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. So here we can see that certain terms will cancel out. My 2x squares will cancel out. My 3x's will cancel out. So I'm left with 3 terms in my numerator. They are 4xh plus 2h squared minus 3h all over h. My numerator, I can factor an h out of every term and get h times the quantity 4x plus 2h minus 3 all over h. We can cancel the h's, and we are left with 4x plus 2h minus 3. So that is the difference quotient. Let's find the domain of g of x equals x over x squared minus 16. So what's important here is where the denominator equals 0. First, let's factor the denominator. So square root of, this is a difference of 2 squares, x squared minus 16. So we will, like the square root of x squared will be x. The square root of 16 is 4, so one term is x plus 4, the other term is x minus 4. And what we need to do is find out what values of x make the denominator 0. So set each factor equal to 0, x plus 4 equals 0, x minus 4 equals 0. Solving, we get x equals negative 4, or x equals positive 4. So the domain is the set of all real numbers such that x does not equal 4 and x does not equal negative 4. In interval notation, that would look like this. We go from negative infinity to negative 4, union negative 4 to 4, union 4 to infinity, and curve parentheses in all the intervals. Okay, let's look at some function operations. We have f of x equals the square root of x, g of x equals 3x minus 5. So part A, what's f of g of x? Sorry, said that wrong. F plus g of x, which is equivalent to f of x plus g of x, which is the square root of x plus 3x minus 5. B is asking for f minus g of x, which is the equivalent to f of x minus g of x, or square root of x minus the quantity 3x minus 5. If I distribute that negative, I get the square root of x minus 3x plus 5. C is asking for f times g of x. So that is a solid multiplication symbol. It's not the open composite circle. This is equivalent to f of x times g of x, or the square root of x times the quantity 3x minus 5. You could distribute this, but it really doesn't make it any simpler. So I'm going to leave it like that. D is looking for f divided by g of x, which is equivalent to f of x divided by g of x, which is the square root of x over 3x minus 5. E is looking for f plus g of 3, This is equivalent to f of 3 plus g of 3, which is the square root of x plus 3 times 3 minus 5, or the square root of 3 plus 4. Now, we could have, well, in writing it in a little bit more standard form, 4 plus the square root of 3. But we could also have recognized that we had found f plus g of x, and we could have taken what our result was there, the square root of x plus 3x minus 5, and replaced the x's with 3. And we would have gotten the equivalent that we got here. F is looking for f minus g of 4. So I can look at what we got in answer B, the square root of x minus 3x plus 5, or I could look at f of 4 minus g of 4 and calculate the square root of 4 minus 3 times 4 plus 5. This simplifies to 2 minus 12 plus 5, which is negative 5. G is looking for f times the product of f and g of 2, which is equal to f of 2 times g of 2, or the square root of 2 times the quantity 3 times 2 minus 5, or the square root of 2 times 1, or just radical 2. H is the quotient of f and g of 1, or f of 1 divided by g of 1, which is the square root of 1 over 3 times 1 minus 5, or 1 over negative 2.